This is section 3.5, problem 12, and the problem states that we're going to use this function, and the graph of it is shown to the right, and we're going to use implicit differentiation to find the slope of the tangent lines for the points on the graph where the x value is 4.8. Notice they said points plural of the graph where the x value is 4.8. If we look at this, we see that there are 5 vertical lines between 4 and 5, which means that each line represents 0.2. So right here we have 4.8, and if we follow that up, we have 2 different points where 4.8 is the x-coordinate. And if we continue to count by 0.2s, we see that we have 5.6 on the y-axis up here. And if we count down, we have 4.4 on the y-axis for the second point. So this top point is 4.8, comma 5.6, and this bottom point is 4.8, comma 4.4. And you can solve this algebraically as well. You can plug in the x value into this equation, replace x with 4.8, and when you solve, you can get these two values algebraically. So our goal is to find the slope of the tangent lines. That means we need a derivative, and it says we're using implicit differentiation. That's because we have a mix of variables in here. So we'll start by writing d dx of each term. And this will use the chain rule. We'll take the 2 down out front using the power rule. And the chain rule says after I do the outside derivative, take the derivative of everything inside. In this case, it's just 1. And the first term becomes 2x minus 8. And then we have plus from the equation. And now we're doing this chain rule again. Take the 2 out in front, subtract 1 from the exponent. So we have 2 times y minus 5 to the first. But when you take the derivative of the inside, we see the variables don't match. So we get a 1 dy dx. So we can simplify this as 2y minus 10 dy dx equals, the derivative of a constant is 0. So here's our implicit derivative. And now our goal is to solve for dy dx. We want to isolate that. So we're going to subtract this 2x minus 8 to the other side of the equal sign. And after we do that, we'll divide both sides of the equation by 2y minus 10. So we have dy dx equals 8 minus 2x over 2y minus 10. And now they want us to evaluate to find the slope of the tangent line. So we have 2 points to do that with. So we want dy dx, the vertical bar. We'll list our point here, 4.8, comma 5.6. And we'll plug 4.8 into the x. So it's 8 minus 2 times 4.8 in the numerator. And we have 2 times 5.6 minus 10 in the denominator. So now we'll enter this into our calculator. 8 minus 2 times 4.8 in our numerator, and 2 times 5.6 minus 10 in our denominator. This gives us a slope of negative 1.3 repeated. 0.3 repeated is 1/3, so this is negative 1 1/3 or negative 4/3. And this bottom line says check your answer visually, estimating the slopes on the graph of the figure. So that's an approximate tangent line. But now let's see if we take a point on this and follow it down 1, 2, 3, 4, 1, 2, 3 over. We say, well, that looks like a good estimation. That's the visual estimation they were looking for. I used a straight edge to keep my line as close to tangent as possible. And we visually obtained the same answer that we calculated with our derivative. So now we'll just do the other tangent point, dy dx of 4.8 comma 4.4. And just looking at that other line, you would expect a positive result from this. So we have 8 minus 2 times 4.8 over, this time it's 2 times 4.4 minus 10. So we'll enter this parenthesis, 8 minus 2 times 4.8, close the parenthesis, that's our numerator, divided by parenthesis 2 times 4.4 minus 10, close the parenthesis, that keeps everything in our denominator. We hit enter, we get a positive 1.3 repeated, which is a positive 4/3, and those are our tangent slopes at each respective point.